right, Math 1, Unit 7, Section 5, Substitution. And just like with the elimination, we're going to have an easy version and then the more difficult version. So, number 1, we're solving by substitution. We're still finding the spot where the lines cross at a point, right? We did that graphically, and then we did it by elimination, and then we did it by substitution. And this is my favorite way to do this. So whenever we say substitution, we're going to substitute in a variable. And I think it'll make a lot of sense with problem number 2, but problem number 1 is a little bit different. We could say the statement that, well, y equals y, right? It's like no diff, yeah. So I'm going to make this y be that y, and this y be that y. And I'm going to substitute in our y's. So I'm going to say, well, negative 6x minus 18 equals 5x plus 15, right? I plugged this guy in from here, and I got this guy from here. Now I'm going to solve, and I'm going to get, what am I going to get? I'll put my x's on the left, so I'll subtract 5x from both sides. I'm going to have negative 11x minus 18 equals 15. I'll add 18 to the right, and I get, well, negative 11x equals, what's that going to be? 33. 15 plus 18 is 30, yeah, 33. I divide by negative 11, and x is going to be negative 3. So we have done the substitution part. The rest of the problem works just like how we did with elimination. We have one of our answers. We need to plug back into one of the top equations. I'll pick my, what do I want to pick? I'll pick the bottom equation because I think 5 and 15 are easy to work with. So I'll say, well, y equals 5 times negative 3 plus 15. That's the same thing as y equals negative 15 plus 15, and y equals 0. I write my answer as a point, and my point is going to be negative 3, 0. All right, so there's substitution. Number 2, we want to substitute in for a variable. We have this one already solved for y. Sometimes they won't be solved for y or solved for one of the variables, but in this lesson, I think they all will be. This one is a y equals. I'm going to plug it inside this y there, because really they're the same y. So I'm going to say, well, negative 8x plus 5 times 3x minus 3 is negative 8. Right? I took this here and put it inside that y. I got that. So now I just have to solve for x. I'm going to distribute, let me get rid of that, yeah. Distribute this guy, so I'm going to have negative 8x plus 15x minus 15 is negative 8. This gives me 7x minus 15 is negative 8. 7x is, what happens if I add the 15? Negative 8 plus 15 gives me 7. So x is going to be 1. I go back and I plug in, and I think it would be easier to use the top one because I'm going to be getting a y. I'm solving for y now. So I have, well, y equals 3 times 1 minus 3. Y equals 3 minus 3, and y is 0. So I have the point 1, 0. Now I know both of these had y equals 0. They will not all have y equals 0, okay? Let's look at number 3. This is a nice equation because they've already solved one of them for us. We get y equals negative 4. Really what that's telling us is that we have a, what is that, a horizontal line at the negative 4, right? So I'm going to plug that in there for this y. So I have negative 6x plus 3 times negative 4 equals negative 12. This is the same thing as negative 6x minus 12 equals negative 12, and negative 6x equals 0, so x equals 0. All right, I promise that not all of these have one of the variables equal to 0. So there's x equals 0, here's y equals negative 4, and I have the point 0, negative 4. All right, number 4. Well, this is another one of those that's already solved for y. So I start off by saying, well, y equals y. So I'll use this one here and this one here. So I can say, well, negative 3x plus 22 equals negative 2x plus 14. So if I solve for x, let's move my x's to the left. So I'm going to have negative x, right? I added 2x plus 22 equals 14. I'm going to subtract 22 from both sides, so 14 minus 22 equals negative x equals negative 8. I divide by negative 1, and x equals 8. All right. I need to plug into one of my equations. I'm going to pick the bottom one because I like 2 more than 3. So y equals negative 2 times 8 plus 14. So y equals negative 16 plus 14. Y equals negative 2. See, I told you that there was going to be one without both of them being equal to 0, or one of them being equal to 0. All right, my point is going to be 8, negative 2, and there we are. Next page. All right, this one's nice. We've got a y equals there. So this guy here is going to go inside that y. So I'm going to have negative 2x minus 5, parenthesis, negative 8x plus 18 equals 24. I'm going to distribute my 5 to both of these. So negative 2x plus 40x minus, 18 times 5 gives me negative 90 equals 24. I combine my x's and I get 38x minus 90 is 24. I add my 90 over, so I got 24 plus 90. So 38x is 114. I divide by 38 and x is 3. I plug back into one of the original equations. I'm going to pick the top one because it's already solved for y. So y equals negative 8 times 3 plus 18. So y equals negative, 8 times 3 is 16. Nope, 24. 24 plus 18. So y is going to be negative 6. Yeah, negative 6. I write my answer as a point, 3, negative 6. All right, there we are. Moving on to number 6. This time the bottom one is solved for y. I'm going to plug it in there. So I'm going to have, well, x minus parenthesis, x plus 3 equals 8. I'll distribute my negative 1 to both of these. I get x minus 3 equals 8. My x's cancel and I get negative 3 equals 8. Well, that doesn't make sense, right? Negative 3 does not equal negative 8, or does not equal 8. We need to go back to our first video in the unit. There were two special cases. There was no solution and infinite solution. This one, because it does not make sense, negative 3 does not equal to 8, it's going to be a no solution answer. So my answer is no solution. Okay. Remember that no solution means that the lines are parallel, right? If we were to graph them, the lines are parallel. And if we look here at our equations, we have a 1x here and a 1x there. Our slopes are going to be 1 on both of these, which means that they're parallel. So it kind of makes sense. So I know we don't have very many of them that are no solution or infinite solution. Actually, I don't know if we've had an infinite solution one yet. But you need to make sure that those, or you need to remember that those are options. Number 7, we have our y solved in the top. I'm going to plug them in the bottom. So 12x minus 2 times 6x minus 5 equals 8. So 12x minus 6x, nope, not 6x, 12x, plus 10 equals 8. No, this can't be right. Nope. All right. Did I make a mistake somewhere? Nope, I didn't. So I have 0 plus 10 equals 8. Well, 10 does not equal 8. So this is just like that last one. This is going to be a no solution. All right, just for a second, let me make sure that I don't have too many of these. Nope, we're good. Okay. Number 8. Again, we have one of them solved. I'm going to plug in for this y, and I'm going to have 8x plus 5 times the quantity negative 2x plus 2 equals 6. And I don't know if I've mentioned this, but we always want to make sure that we use parentheses when we plug in, right? You can't, well, yeah, you just have to use the parentheses all the time. So 8x minus 10x, right? I'm distributing, plus 10 equals 6. This gives me negative 2x plus 10 is 6. Negative 2x is negative 4, right? I subtracted my 10. And x is going to be a plain old 2. I go back to plug in. I'm going to use the bottom one. And I say, well, y equals negative 2 times 2 plus 2. Lots of 2's. This is negative 4 plus 2, which is negative 2. So I have the point. What is the point? It's xy, so 2, negative 2. All right, there we are.